Howdy, howdy, this is Mr. Potter. In this video, we're going to be doing some simple math tricks, just some fun with numbers. And so we're actually going to start today's lesson proving that 1 equals 2 using some simple algebra. So I'm going to start with a very basic assumption here. I'm going to start with the assumption that A equals B. And of course, if A equals B, then I can multiply both sides of this equation by A, and so I end up with A squared equals A times B. Again, if I'm doing the same thing to both sides, that's not anything wrong with mathematics. And I can add A squared to both sides. So on this side, if I do that, I get A squared plus A squared. And if I add A squared to this side, I end up with AB plus A squared. And I know that A squared plus A squared is going to give me 2A squared. And normally when we write polynomials, it's usually better to write it with a leading term in front. So this is A squared plus AB. And so I've got some mathematical expressions here. And what I'm going to do now is I'm going to subtract 2ab from both sides. So this side's going to become 2a squared minus 2ab. And over here, I'm going to take the same a squared plus ab and subtract 2ab. So on this side, I've got 2a squared minus 2ab. And on this side, I'm going to have a squared. And these are like terms, so a positive 1 and a negative 2 is going to make that a negative 1, so that would be negative AB. So I've got these expressions here, and what I can do on this side is I can actually factor out a 2, leaving a squared minus AB. Over here, they don't have a common factor, but I do know that 1 goes into everything, so I can factor a 1 out and get a squared minus AB. And then I can divide both sides by a squared minus AB. Of course, if I divide this side, those will divide out, leaving me with a 2. And on this side, when I divide, I'm left with a 1. So I proved that 2 equals 1. Of course, once you've proven that 2 equals 1, you really can prove almost anything. So I'm going to use geometry to prove that 63, 64, and 65 are all the same number. So I've got several different rectangles here. I've got a rectangle here up to this point that has a volume or an area of 30 because it's 5 units tall and it's 6 units wide. Similarly, I've got a rectangle here that also is 5 units tall, 6 units wide, so it has an area of 30. And I've got this middle rectangle here that's a 1 by 3, so this has an area of 3. So this total figure here has an area of 63. But what I'm going to do now is I'm just going to take these shapes and I'm going to rearrange them in a slight way. Take this shape and rotate it. And then take this shape and rotate it. Actually, I don't need to rotate it. I just need to put it over here. And now what I've got is I've got a rectangle that's 8 units tall and 8 units wide, and 8 times 8 is 64. So this figure now has an area of 64. But it's the exact same shapes. I've just arranged them differently. Well, now I'm going to arrange them again once more. I'm going to put this one over here. And I'm going to take this shape and I'm going to rotate it and move it right here. I'm going to take this shape, rotate it, and move it over here. And take this shape and put it right here, straightening these up a little bit. But now what I've got is I've got a rectangle that's 5 units wide and 13 units tall, and 5 times 13 is 65. So by using these same 4 shapes, I've shown that 63, 64, and 65 are all the same because they can all be made from the same shapes. Of course, once you've dealt with positive numbers, negative numbers aren't a problem to work with either. So I'm going to prove now that 1 equals negative 1. But I'm going to need a little algebra 2 here. I'm going to need to use the idea of I. Now I know that I is equal to itself. That's the reflexive property of mathematics. And I know that I is defined to be the square root of -1. This is this imaginary number that we learned in Algebra 2 that we work with so much in pre-calculus. And I know that I can write any number as a fraction by putting it over 1. So I could say that -1 equals -1 over 1. But in that same vein, I could take this -1, and it really doesn't matter if I put the negative on top or if I put the negative on the bottom. So I've got 1 equals -1, or 1 over -1 is the same thing. And I know that whenever I take the square root of a fraction, that's really the square root of the numerator over the square root of the denominator. So I can do the same thing on both sides, just rewriting this radical as a ratio of radicals. And now to get rid of the division, I can multiply both sides by the square root of 1 and the square root of -1. So if I multiply both sides by the square root of 1 and the square root of -1, then all I'm doing is I'm rewriting this, because now this 1 will divide out with this 1. And this -1 will divide out with this -1. And so I end up with the square root of -1 times the square root of -1. Well, that's really just I times I. And over here I've got 1 times 1, which is 1. So I end up with I squared equals 1, or -1 equals 1. Just using the properties of algebra that we've learned, just doing the same thing to both sides of the equation, we can prove all of these things are amazing. And I don't want to leave calculus out, so we're going to do a calculus proof to prove that 1 equals 2 as well. So I'm going to start with the idea that x equals x. And of course, remember that when I say x, this is really just 1 plus 1 plus 1 plus 1 plus 1, and this is going to occur x times. So I've got x is really equal to 1 plus 1 plus ... plus 1 x times. And then I can take this expression and multiply both sides by x. So x times x is x squared. And if I multiply this expression by x, I'm going to have x and x and x and x. I'm going to have x of these x's. Well, if this is true, if these truly are the same thing, then I can take the derivative of both sides. The derivative of x squared is 2x. And the derivative of all of these is going to be 1 plus 1 plus 1 plus ... plus 1. And again, I haven't lost any of these terms. I still have the same number of terms. It still occurs x times. But now remember that 1 plus 1 plus 1 plus ... plus 1 is equal to x. So I've got 2x is equal to x, and then I can go ahead and divide out that x, and I end up with 2 equals 1. So I can do it using algebra, geometry, complex algebra using complex numbers, or calculus. I can prove all of these interesting math facts. Of course, each one of these had a mistake. So, April Fools, what I'd like you to try and do is tell me on each of these problems where you think the mistake was. Go ahead and write the answer down in the comments down below. Once again, this is Mr. Potter. Thank you for watching. Have a great day.